Our suspicion was that Europa might be the finest place in the solar system to potentially encounter extraterrestrial life. In October 2024, 42 years later, NASA will send the most sophisticated expedition to search for evidence of extraterrestrial life, to the moon Europa of Jupiter. There is only one issue: Jupiter destroys everything in its vicinity. How, therefore, is life possible there? And how can a probe be made to survive the dangerous circumstances? The lethal belts of radiation on Jupiter. Hydrogen is thought to exist as a metallic liquid due to the extreme pressure found deep within Jupiter. Even at the same distance, the magnetic field produced by this metallic liquid hydrogen is over 20,000 times stronger than Earth's. Thus, from Earth, this magnetic field would appear twice as large as the full moon. That magnetic field is harmless on its own. However, Io, the moon of Jupiter, is located directly in the center of it and is the solar system's most volcanically active planet. Each second, 1 ton of sulfur dioxide emitted by the volcanoes on the surface of Io is ionized and imprisoned within Jupiter's magnetic field. These particles revolve extremely quickly with Jupiter due to the acceleration caused by the field. So, they are traveling at more than 300 kilometers per second. On the field, their inertia actually lengthens it by pulling back. Additionally, this imprisoned material ejects more particles from the surfaces of other moons as it collides with them. Beyond Europa and Jupiter's other moons, this cycle creates enormous radiation belts. Now, this powerful radiation is the death blow for electronics. Although the Pioneer 10 and Voyager missions only made a fleeting visit to Jupiter in the 1970s, the radiation led to malfunctions, misdirected the sensors, and tainted some of their data. Within the radiation belts, a spaceship would only last around 3 months, even with the most advanced shielding. How, therefore, would the Europa Clipper, NASA's new mission, orbit the continent for more than 4 years without getting burned? It won't, is the answer. After circling Jupiter in a distant orbit, it will swiftly fly past Europa every few weeks before departing once more. Additionally, the mission can use the downtime while it is out here to send all of the data it will be collecting back to Earth before making another swoop. With 49 flybys overall, it will map nearly the whole surface. In fact, the Clipper's name was inspired by the swift and agile clipper ships of the 19th century, which constantly dipped in and out of ports. What makes Europa the best spot in the solar system to search for life? One day would expose you to 5,400 millisieverts of radiation if you were standing on the surface of Europa. That's 1,800 times greater than what we get here on Earth each year. You would eventually perish from radiation sickness if you stayed here for a few hours. Europa, however, has a secret. Europa's secret. This image of Europa was captured by Voyager 1 during its 1979 orbit around Jupiter. You'll note that craters are absent when comparing it to the majority of the other moons in the solar system. Asteroids have been pelting every planet and moon for billions of years. The majority of planetary surfaces exhibit it. Not Europa, though. So why not? The majority of these craters must have been removed from the surface of Europa by some recent process, perhaps within the last 60 million years. Jupiter was reached by Galileo 16 years after Voyager. The gas giant and its moons were studied for 8 years. On Europa, Galileo's magnetometer also detected an intriguing object. The magnetic and geographic poles of Jupiter and Earth are not in line. Thus, the entire magnetic field wobbles from the planet's 10-hour rotation. On Europa, this shifting field from Jupiter creates a magnetic field, and a rather powerful one at that. Europa must therefore have an electrically conductive layer that responds to Jupiter's field. Galileo's measurements also suggest that it must be merely tens of kilometers deep, near the surface. Which type of conductive layer is it, then? The thick layer of water ice that covers much of Europa's white surface is called a crust. According to spectrometer observations, these reddish-brown areas could be bacteria, sulfuric acid, hydrated salts, or many other substances. Although more data is necessary, recent JPL studies have shown that sea salt changes from white to the similar brownish color seen on Europa when exposed to high radiation levels. Scientists believe that Europa may have a 200-kilometer deep saltwater ocean, which would mean that the continent had twice as much water as the entire Earth. And the geological activity that continuously renews and soothes the Moon's surface must be its driving force. The reasons behind the partial freezing of Europa. However, the Jupiter system receives only 4% of the sunlight that we receive on Earth. Since the temperature of Europa's surface is consistently below -160 degrees Celsius, you would anticipate that the ocean would be frozen solid. However, there is an alternative to using the sun to produce heat. And to demonstrate it, I've included a brief demo. There are irregularities in Europa's orbit around Jupiter. The reason for this is that Ganymede, Europa, and Io are in orbital resonance. Europa completes 2 orbits for every Ganymede orbit, and Io completes 4. This causes Europa's orbit to become increasingly eccentric as Io pulls it inside on one side and Ganymede pulls it out on the other. The closer side of the orbit is now subject to a greater attraction from Jupiter than the farthest side. Europa is therefore continuously being squeezed and stretched. As you can see, when I compress this rubber ball, it gets warmer. According to scientists, the friction created by the Moon's complete tidal flexing can produce enough heat to maintain the ocean's liquidity. Io is extremely volcanically active because of this phenomenon, which intensifies the closer you are to Jupiter. As you can see, the ball is much hotter now. To make sure it wasn't just the heat from my hand, I held on to this ball at the same time. We're thinking of what kind of ocean temperature? The degree of saltiness determines this. The melting point of ice, or perhaps 10 degrees Celsius lower if the water is extremely salinized. Consequences of tidal flexion. As frigid as the oceans on Earth. And how would the flexing change if there was a large liquid ocean instead of none at all? Europa should only bend with an amplitude of roughly 1 meter if there is no ocean. However, if an ocean is present, it flexes with a 30-meter amplitude. That is a significant diversion. And the gravity data will make that very evident. Another indication of the thickness of the ice shell is the appearance of these odd surface features, which are shaped like arches but resemble several arcs joined together. They are known as cycloids. You wouldn't expect to see that on a frozen moon. We believe that they develop when a crack follows the shifting stress field of Europa as it revolves around Jupiter and spreads at the ideal pace, roughly the speed at which a person would walk. Furthermore, there wouldn't be enough amplitude of that motion to account for the cracking if there were no ocean down there. However, the presence of an ocean might account for the breaking. Magma in the outer core rises and approaches the seafloor as a result of all that tidal bending. Why life could exist in space. As hot water moves through the crust above it, minerals are drawn up from the Earth and ejected into the ocean. Thus, hydrothermal vents are produced. Additionally, life can be found on Earth when these are found. Ocean life finds refuge in these vents, which are located thousands of meters below the surface and receive no sunshine. Down here, life forms depend on special bacteria that consume the minerals from the vents instead of the sun's energy. How long has Europa had an ocean, in our opinion? We are unsure, it might be 4 billion years. Could life in those oceans have had the chance to evolve over that long? It's precisely right. Carbon dioxide, sulfur, and methane processes can all be used by organisms. Any possible chemical reaction that could occur in the ocean has the potential to be utilized as fuel for the metabolism of that creature. Instead, we are seeking for single-celled organisms, not fish, whales, squids, or anything else down there. We were so worried that Europa may have life that, in 2003, as the Galileo mission was coming to a conclusion, it was purposefully slammed into Jupiter to prevent the possibility of contaminating Europa. However, the kilometers of ice crust will be too thick for Clipper to bore through. Therefore, how will we discover proof of life beneath that dense layer? How Europa Clipper looks for life. Introducing the Snotbot. Here on Earth, a drone that has petri dishes connected to its top flies straight through whale blows to gather whale snot. Additionally, zoologists can retrieve a variety of biological data about whales using the snotbot. We can also accomplish something pretty similar with celestial bodies, it turns out. Photographs of water geysers erupting from Saturn's moon Enceladus, which contains an underground ocean, have actually been taken. Additionally, there is some evidence of what may be comparable geyser outbursts on Europa that the Hubble Space Telescope has detected. With the help of a mass spectrometer, Clipper is hoped to fly through one of these plumes, similar to the snotbot, and disclose its chemical makeup. However, there is inconclusive evidence for an ocean on Europa. Why not Enceladus, as it appears to be a more formidable contender? We have flown over its plumes and have even seen pictures of them. The existence of a subterranean ocean there is nearly definite. Why is Europa more appealing to you than Enceladus if Enceladus has these plumes and there may be a liquid ocean there? Do you have any particular attraction? Enceladus might have simply started up its engines, but Europa has probably been well evolved over a long period of time. We don't know how long life takes to begin underway. Europa is surprisingly a better choice because of its exposure to Jupiter's radiation. Those fast-moving particles that strike the surface of Europa provide enough energy to molecules of carbon dioxide and water to create new chemicals like hydrogen peroxide and formaldehyde. And if they are able to descend so far, these can provide nourishment for life below. Additionally, there is evidence of the icy shell overturning in chaos zones, where it appears that the icy crust has smashed and material has been pushed into the ice shell. Thus, this life-giving substance might find a way into the cold shell and possibly the ocean. Instruments of Europa Clipper. To verify this, Clipper does not need to land on the ground. To determine the location of the salts and determine whether organic materials are present, an infrared spectrometer is used to examine the chemical fingerprints of light that bounces off the surface. To search for plumes, the spacecraft is equipped with an ultraviolet spectrograph. Do they exist? Is it possible for us to fly through them? Then there will be imaging of practically the entire world with a resolution of more than 100 meters per pixel. The wide-angle camera is the one that will capture broad swaths of photographs as we fly over the surface. Afterward, there comes the narrow-angle camera. It will receive half-meter per pixel photos from a height of 50 kilometers, correct? Thus, if it were on Europa, it could fix my desk here. Then there would be a mission in the future, such as a lander that would go and look for life on Europa. Do you believe that a lander would be able to survive? We can get a lander to live on the surface for a month, according to certain studies. Take some material from below the depth of radiation processing, put it in a mass spectrometer, and see what we get if we believe that's enough to go inside. However, Jupiter's moons won't be the only thing the Europa Clipper is researching. The Jupiter Icy Moon Explorer, or JUICE mission, is now its route to Jupiter via the European Space Agency. Only 15 months after Clipper, it will enter the system and even make a few flybys of Europa before settling into a close orbit around Ganymede. Thus, the European Space Agency will simultaneously have a mission there as well. Yes, members of the JUICE science team are speaking with us informally. If two spaceships were present simultaneously, what would that mean? The JUICE mission will eventually circle Ganymede, which has its own magnetosphere. We will be outside the magnetosphere of Ganymede, though. We could say, oh, look, there's this big burst coming from Jupiter. JUICE could respond, oh, we felt that over here in our magnetic signals. This would mean that we wouldn't really need to do anything different, other than communicate with each other and ensure that the whole is greater than the sum of its parts. Date of launch and initial outcomes. NASA has set the launch date for Europa Clipper as October 10, 2024, but the spacecraft cannot safely take off until Hurricane Milton has passed Florida. When might we expect to get the first results? In 2030, you will begin to see distant observations arriving as we seek for plumes while viewing Europa from a distance. In 2031, you'll view the first truly high-resolution data. How does it feel to get so close to launch after, say, 26 years of considering a trip to Europa? It's a little weird, I must admit, laughs. It's been so long since this happened. Sometimes I'm reminded that our spacecraft will soon be in the sky, heading straight toward the stars. NASA really video called Arthur C. Clarke at a Europa Ocean conference in the late 1990s, it turns out. Clarke also let NASA land on Europa after presenting him with plans for a future trip to investigate the distant ocean world. A prime illustration of the incredible things we can accomplish when we set high standards for ourselves and collaborate with others to meet them is Europa Clipper. But I believe we frequently lose sight of the enormous impact we might have on the world because we are so preoccupied with our daily lives. Both at the individual and societal levels, such as these large international space missions, I believe that to be true. It is likely that you are capable of much more than you realize in terms of improving the world. And that's what today's sponsor, 80,000 Hours, wants to help you do. Nothing is being sold by them. 80,000 Hours is a non-profit organization that can assist you in creating a strategy and carrying it out to make a significant, beneficial influence on the world. The goal of most career guidance is to assist you in locating a position that aligns with your preferences. However, what if you genuinely want to impact the world? Indeed, they can advise you to pursue a career in medicine or education, but these aren't your only choices. Thus, 80,000 Hours has spent more than a decade researching how to find a fulfilling profession that causes a lot of good. They have everything from a podcast about the world's most important issues and how we might address them to a comprehensive career guide. Hundreds of high-impact career opportunities are listed on their carefully maintained job board. Additionally, they offer everything for free, forever. Therefore, if you wish to use your 80,000 hours to influence your career, enroll now at 80,000 Hours. As a result, I would like to thank 80,000 Hours for sponsoring this video and thank you for seeing.